Welcome to my tutorial on dependent sources. As usual, we will start with the simple circuit and then slowly we will develop the concept of dependent sources. The diagram which is shown on the slide, it is a voltage divider circuit consisting of 10 volt supply and resistors R1 and R2 having value 5 ohms each. The voltage across R1 is shown as V1. If I want to calculate V1, I will calculate it by voltage divider formula, which is R1 divided by R1 plus R2 into the total voltage applied V. I will put the values, so it is 5 divided by 5 plus 5 into 10, that comes to be 5 volt. Now this is equal to 5 volt. Now I will connect a bulb across this source. And when I connect the bulb, my diagram would be like this. Now bulb is a load and now bulb will glow due to the voltage V1. Now suppose I change the value of V from 10 volt to 20 volt. What will be the change in V1? Now V1 will be equal to 5 divided by 5 plus 5 into V. V is now 20. So V1 is equal to 10 volt. From this, what we can say is V1 is acting as a source or voltage source, and it is driving the load, which is a bulb here. But my V1 depends on V, because when V is 10, V1 is 5. When V is 20, V1 is 10. So V1 is directly proportional to V. So V1 is equal to, we can write kV. So what we can say, V1 is a voltage source, but it is a dependent voltage source because it depends on the value of V. So dependent voltage source is shown by the symbol, which is the diamond shaped symbol. Now we can redraw our second circuit, which is this one, with the help of symbol. Now both the circuits are same. So V1 is now represented by 0.5 V. So from where that 0.5 has come, see, V1 is equal to kV. So K is equal to V1 upon V. So in the first case, here V1 is 5 and V is 10. So 5 by 10, that is equal to 0.5. And in second case, V1 is 10 and V is 20. So 10 by 20, again it is equal to 0.5. So 0.5 is K and V is the voltage on which V1 depends. So this is what is the symbol of voltage controlled voltage source. Why it is known as voltage controlled voltage source? Because my V1, which is a voltage source now, and it depends on the V. So this is the first type of the dependent source known as voltage controlled voltage source, or in short VCVS. We will see few examples of it in the next slide. Transformers and amplifiers are some of the examples of voltage controlled voltage source. How? Let us see. This is the symbol of the transformer. It is shown here. V1 is the primary voltage, N1 is number of turns at the primary side, N2 number of turns at the secondary side, and V2 is the secondary voltage. We know in transformer, the relation between V2 and V1 is given by V2 by V1 is equal to N2 by N1. So if I want to know now V2, so V2 is equal to N2 upon N1 into V1. Now suppose N2 is equal to 10 and N1 is equal to 100. And if I put these values, what I will get, V2 is equal to 10 divided by 100 into V1. So V2 is equal to 0.1 V1. Now from this we can say V2 depends on V1 by the factor 0.1. So this is acting as a voltage control voltage source, and it is shown by the symbol like this. So 0.1 is your K and V2 is your output voltage. So I can write it here as V2 equal to 0.1 V1. So V2 depends on V1. So transformer is treated as voltage controlled voltage source. Similarly, we can go for amplifier. See this circuit. Here we are having V1 is the input voltage, V2 is the output voltage, and gain of the amplifier is 10. So I can write V2 is equal to 10 into V1. That means V2 again depends on V1 by the factor K 10. So this circuit is also acting as a voltage controlled voltage source, and it is represented by this symbol. So here again it is clear your K is 10 and it depends, your V2 depends on V1 by factor 10. So these are the examples of voltage control voltage source. Next slide we will see the next dependent source. The second type of dependent source is current controlled voltage source. See the diagram for this. Here it is shown a simple series circuit. The current source is shown of 1 ampere and that 1 ampere current is flowing through both the resistors R1 and R2. And if I want to calculate now V1, so V1 I will write it as R into I. Whereas now in this case R is equal to 5 ohms and current flowing in the circuit is 1. So V1 is equal to 5 volt. Now suppose I change I from 1 ampere to 2 ampere. What will happen? So when I is becoming 2 ampere, obviously V1 which is equal to R into I. So R is saying 5 into now 2. So V1 is 10 volt. Now from these two simple calculations, what is our conclusion? V1 depends on I. So my voltage source V1 is depending on the current I. So that's why it is known as current controlled voltage source. So we can write it as V1 is equal to Ki. So where K is equal to V1 upon I. V1 is my output, I is my input. The symbol for current controlled voltage source is like this. Here we are having plus and minus and the K into I, where K is equal to V1 by I. Now if you see the third circuit where bulb is connected across the source which is equal to 5 volt, but it is represented by 5I. From where that 5 has come, again it is clear from the first two calculations. See, K is equal to V1 upon I. In first case my V1 is 5, this one, and I is 1. So this is equal to 5. And in second case my V1 is 10, at that time I is 2, that is equal to again 5. So K is 5 and my voltage source depends on I, that's why it is written as 5I. So this type of source is known as current controlled voltage source, or in short CCVS. Next slide we will see the next dependent source. The next dependent source is voltage controlled current source. The diagram is taken to understand this voltage controlled current source is a simple parallel circuit. Here from the diagram it is clear that if I want to calculate I2, then formula for I2 is V upon R2. So V is how much? It is 10 and R2 is 5. So my I2 becomes 2 ampere. If I change this 10 volt to 20 volt, obviously I2 will change. So I2 is again V by R2. So that is equal to 20 by 5, that is equal to 4 ampere. Now I can write I2 is directly proportional to V. And so I can write I2 is equal to KB, where K is equal to I2 divided by V. Now you can see here the symbol of voltage controlled current source. Here arrow is there inside the diamond shape to indicate it is a current source. Now this diagram is shown, which is replaced by the dependent source symbol. Here I can get the value of K as I2 by V. So how much is I2 in first case? I2 is 2 divided by V is 10. So that is equal to 0.2. And in second case also my I2 is now 4 and V is 20, so that is equal to again 0.2. So K is zero point 0.2 here, and this is my current source which is depending on the voltage. So I can write this is I2, so I2 is equal to 0.2 V. This is known as voltage controlled current source, or in short VCCS. FET and MOSFET are the examples of voltage controlled current source. Let us see how. This is the symbol of FET. We know in FET, this is the gate terminal, this is the source terminal, and this is the drain. Here we apply the supply VDD, and here we apply the controlling voltage VGS. Now, the working principle of FET is the drain current ID depends on the input voltage VGS. So ID is proportional to VGS. So we can see from this equation that current depends on voltage. That's why it is voltage controlled current source. So we can write it as ID is equal to K VGS. So K is equal to ID upon VGS. Symbolically, FET is shown like this. So this is my voltage VGS on which my current is depending, and the output is voltage dependent current source. So this is what is my current source, where I will write K into VGS, which is equal to ID. So this is what is the representation of FET in the form of a dependent source. The last type of dependent source is current controlled current source. The simple parallel circuit is shown, and now suppose I want to calculate the current I2. I will calculate by current division formula, that is R1 divided by R1 plus R2 into I. If I put the values, I will get it as 5 divided by 5 plus 5 into 4, that is equal to, now I2 is equal to 2 ampere. Now suppose I change this I to 8 ampere. Now, and if I use same formula again to calculate I2, so what I will get, I2 is equal to 5 divided by 5 plus 5 into 8. So I2 is equal to 4 ampere. Now from this I can conclude that I2 current is directly proportional to I. That means my current I depends on input current I. That's why it is known as current controlled current source. So finally I can write I2 is equal to Ki. So K is the constant, which is equal to I2 divided by I. The symbol for current controlled current source is this. Again, arrow indicates the current source, and this I indicates that my I2 depends on the input current I. The diagram with dependent source is shown like this, and from this diagram again see this 0.5 is calculated by this formula of K. K is equal to I2 upon I. In first case my I2 is 2 ampere upon I is 4, that is equal to 0.5, and in second case it is 4 by 8, again that is equal to 0.5. So current 0.5 I, that is equal to I2. This is what is known as current controlled current source. BJT is an example of current controlled current source. The symbol of BJT is shown in the figure. We know from the working principle of BJT that collector current IC, which is the output current, it is proportional to IB. So when base current increases, IC increases. If base current decreases, IC decreases. So we can say that output current is dependent on input current. So this BJT can be modeled as current controlled current source. So I can write it as IC is equal to beta IB. Now in previous slide we have taken K. Now in this case we know that beta is equal to IC by IB. So beta is acting as a K. The symbol for BJT as a current source or dependent current source is shown in the figure. So in this case what we know is IC is equal to beta IB, and suppose you want to show the input side, so it depends on IB, so it can be shown like this. So this is my IB, and this is my output side. So this is what is my total symbol for BJT as a dependent source. In nutshell, we can say that dependent source depends on some other quantity in the circuit, which may be either voltage or current. Dependent source is not a separate device, it is just a model. Dependent source is used in model to make overall behavior of the circuit easier to understand. Dependent sources are used to represent electrical properties of electronic devices such as op-amp, BJT, FET, etc. Thank you for viewing my video. If you are really satisfied, please share and subscribe to my channel. Thank you once again.